In this video, we're going to go over combining random variables. Okay, before we can get too ahead of ourselves, we're going to start off with the basics of linear transformation. So the formula for a linear transformation line is y equals a plus bx, x representing the random variable. So the shape is going to be the probability of the distribution y has the same shape as the probability of the distribution x if b is greater than 0. Additionally, the center of u of y is equal to a plus b u of x. The spread is going to be the standard deviation of y equals the absolute value of b times the standard deviation of x. Absolute value is simply because b could be a negative number. This applies to both discrete and continuous random variables, so you need to keep that in mind when you're solving your problems. Now that we are aware of the basics of linear transformation with a random variable, we are ready to move forward by seeing the effects on standard deviation and the mean when we go about combining random variables.
Okay, so on to the next slide. So on this slide, if you add x and y, because x and y are two random variables, then the mean would just be the mean of x plus the mean of y. Same thing with subtracting, except it would be mean of x minus mean of y. So this gets a little bit more complicated. Don't just add the standard deviation. Make sure that you add the variance. So if you're adding x and y, then find the variance of x, and then add that to the variance of y to get the variance of the new variable. And just make sure you don't do standard deviation. And for subtraction, make sure you don't subtract the variances. Add the variances too.
Now we're gonna take a look at a couple examples. So first off, we're gonna look at a basic example, and then we're gonna look at a little bit more difficult one. The first one is gonna involve linear transformation, and the second one is just going to be combining two random variables. Alright, so let's get started. Mr. Keenan's class was unhappy with their test scores, so Keenan decided to curve the test. Let's assume that the mean score was 60 points with the standard deviation at 3.6 points. Mr. Keenan states that he will double all scores and then add 20 points to each score. What is the mean and standard deviation for the new scores? All we're going to do is multiply by 2 and then add 20 to reach a combined mean of 140 points. And then for the standard deviation, we are simply going to multiply by 2 to get 7.2 points. We don't need to add 20 here because we are just looking at spread. And the next example reads that Mr. Keenan and Ms. Dobashi want to combine their recent test statistics. Mr. Keenan's class had a mean of 60 points and a standard deviation of 3.6 points, while Ms. Dobashi's class had a mean of 45 points and a standard deviation of 4.2 points. What is the combined mean and standard deviation? So once again, we're going to look at the equations listed for combining two means and combining two standard deviations. And first we're going to combine the means, and in this problem we simply just had to add the two means of Mr. Boshi's and Mr. Keenan's class. So 60 plus 145 is 105 points, so that is the new combined mean. And then when we add the standard deviations, it gets a little bit more complicated because we actually have to add the variances. So to do that, we are going to square both standard deviations of both classes to get their variances, which would be 3.6 squared plus 4.2 squared, and we add them, we get 30.6, and then we need to take the square root of that, which is the combined variance, and once we take the square root of that, we will get the combined standard deviation, which is 5.53 points.
So here we have listed a few cautions, tips, and common mistakes. The first tip is that if you are provided with two means and you are instructed to combine them, you just add them together. And if you are asked for standard deviation, use the one given. Secondly, mean and standard deviation convert normally in scenarios where it's a simple metric conversion. However, if you are given a conversion formula, it is slightly different. The mean is calculated the same, just plugging it into the conversion formula, but standard deviation is only multiplied in the formula, not added to the additional constant. View the example below for clarity. Another common mistake is that when a problem asks for the sum of mean scores, students will often get confused with the other numbers provided, such as standard deviation. Look at the example below and pause the video. Lastly, a major caution is that never add the standard deviations together. You can only add variances together.
On the screen, you'll see a list of relevant AP test questions to the concepts we've taught. You are now ready to try these out.